Hello all, welcome back. This video we are going to write simple programs using two-dimensional arrays. The first program is to just read and display the contents of a two-dimensional array. I'm going to get input from the user. Right. So the main function starts. I have declared my array of type integer. The name of the array is ARR. There are 3 rows and 3 columns. I and j are variables, integer variables. So now I'm going to enter 9 elements. So printf reads enter 9 elements. User is ready to enter 9 elements. How should I read my values of a two-dimensional array? I should use a nested for loop. Again, I appreciate you people to look into nested for loop video before coming to two-dimensional arrays. Fine. So the first for loop reads I equal to 0, I less than 3, I plus plus. So this outer for loop is for rows. The inner for loop j equal to 0, j less than 3, j plus plus is for the columns. So now scanf reads %d ampersand arr I j. So now the 9 elements. How does the 9 element look like? 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. So these are the 9 elements. All 9 elements are read from the user. I'm going to print or display these 9 elements. How should I print or display these 9 elements? Use again the nested for loop. For I equal to 0, I less than 3, I plus plus. For j equal to 0, j less than 3, j plus plus. Printf %d arr I and j. So now all 9 elements will be printed or displayed. So this is a very simple example to understand how to read and display elements of a two-dimensional array. Fine, let us move on. So the next example is a very basic example or a classical example of a two-dimensional array. So we are going to talk about matrix addition. All of us have added 2 matrices in our middle schools. So you all know how to add 2 matrices. The matrix addition rule is that 2 matrices can be added only if they have the same number of rows and columns. If they don't, we cannot add. That is the only rule that you have to check. Right. Come, let us code. So start the main function. I have 3 matrices. Right. Why? Because A and B will be input. I am going to store the addition in sum. I'm going to add A and B and store the result in sum. Right. Now look into A, B and sum. A is a two-dimensional array. B is again a two-dimensional array. And sum is also a 2D array. The row size and the column size of all 3 arrays are 10 cross 10. Fine. Now I say enter number of rows and columns. Okay. So I am entering the number of rows and columns. So these can vary from 2 or 3 or 5 up till 10. Done. I am asking the user to enter the elements of matrix A. So how should I get the elements of matrix A? Use nested for loops. Outer for loop for row, inner for loop for column. So nested for loop reads like this. I equal to 0, I less than r, I plus plus. R is nothing but number of rows. J equal to 0, j less than c, j plus plus. C is nothing but number of columns. You read the contents of the array using ampersand a of I, j. Right? Similarly, you read the contents of the matrix B also. Done. Now the user would have entered the elements of matrix A as well as matrix B. Fine. Again use the same principle of nested for loop. Done. Find the sum. How should you find the sum? Sum of I comma j is equal to A of I comma j plus B of I comma j. Done. The sum is found. Print the resultant matrix. Resultant matrix is nothing but sum. Use nested for loop. For I equal to 0, I less than r, I plus plus. J equal to 0, j less than c, j plus plus. Print the sum value. And this is how you do the matrix addition. So this is a very classical example of understanding two-dimensional arrays. Done. So we are done with matrix addition. Again, moving on, this is how your sample input and output looks like. Fastly moving on, we have another important interesting problem on matrix multiplication. You all would have done matrix multiplication also in your mid-school. Likewise, there is a rule for matrix multiplication, right? So if matrix A is R1 cross C1, matrix B is R2 cross C2, the multiplication is possible only if the column 1 is equal to row 2. So if this is there, the resultant matrix, the resultant product will be of size R1 cross C2. So this is a global understandable rule for everyone. Right. So this is the formula. So you find the product or the result of I comma j as summation of A of I comma k into B of k comma j. So now comes an important person here called k. So we have to understand this carefully. Let us try to understand. Right. So my matrices are A, B and multiply, MUL. So I ask the user to enter the rows and columns of matrix A and matrix B. Right? Done. R1, C1 are rows and columns of matrix A and R2 and C2 are rows and columns of matrix B. Now I should check for the multiplication condition. If C1 is not equal to R2, I cannot do matrix multiplication. I cannot even write my program. So if C1 is equal to R2, now I input the elements for matrix A. Look, I am using the nested for loop as discussed previously. I equal to 0, I less than R1. R1 is the row of matrix A, I plus plus. J equal to 0, J less than C1. C1 is the column of matrix A, J plus plus. Inside the nested for loop, scanf reads %d ampersand A of I comma J. So now the user enters the elements of matrix A. Likewise, the user enters elements of matrix B. Done. I have to go to the core part of matrix multiplication. Right. So before multiplying, I initialize my multiply to 0. Right. Okay. So we have already seen why I initialize to 0. Please look into the previous examples. Done. Coming to the core part of matrix multiplication logic, you will find 3 loops here. For I equal to 0, I less than R1, I plus plus. R1 belongs to row. For j equal to 0, j less than C2, j plus plus. C2 belongs to column 2 of matrix B. R1 belongs to A, C2 belongs to B. And there is a innermost for loop which says for k equal to 0, k less than C1, k plus plus. So outer loop I chooses the row of matrix A. The middle loop J chooses the column of matrix B. The inner loop K performs the multiplication and summation. So this inner loop is the heart of matrix multiplication. So this is how. So multiplication of I comma j plus equal to A of ik into B of kj is nothing but multiplication of ij is equal to multiplication of ij plus aik into bkj. So this is the core part or the heart of the matrix multiplication logic. So after multiplying, again I use my for loops. For I equal to 0, I less than R1, I plus plus, j equal to 0, j less than C2, j plus plus, and print my product, multiplication of I comma j. So that is it. This is how matrix multiplication is being done using a 2-dimensional array. So try it, trace the program. If there is any doubt, post it. I'll be happy to clear your doubts. Thank you. Happy learning.